First, we have to understand the standard pack of 52 playing cards. So, in the standard pack of 52 playing cards, there are four suites, and those are spade, heart, club, and diamond. And each suite has 13 cards. In other words, ace, 2, 3, up to 10, jack, queen, and king. Now, all the clubs and spades are black. Diamonds and hearts are red. And all the jack, queen, and king cards are also known as picture cards. So, hence, we have understand the standard pack of 52 playing cards. Now we will see the statement of the question. A card is drawn at random from a standard pack of 52 playing cards. Find the probability of drawing a king or a jack. So for the number of a king, for the probability of drawing a king or a jack, first we have to find out the number of kings and jacks in a pack. And that will be equals to, since we have four suites in the standard pack of 52 playing cards, so each suite have its own kings and jacks. So in total, we have four kings, add four jacks, and that will be equals to 8. And the total number of playing cards is equals to 52. So now the probability that the card is drawn is a king or jack will be equals to 8 over 52. And after simplification, it will give us 2 over 13. So the probability that the drawn card is a king or jack will be equals to 2 over 30. Now in the part 2, we have to find out the probability of drawing neither a king nor a jack. So for this, we'll subtract the probability of drawing a king or jack from 1, and that was 2 over 13. And here we have 13 minus 2 over 13. And after subtraction, we will get 11 over 13. So the probability that neither king nor jack will be equals to 11 over 13. Now in the part 3, we have to find the probability of drawing a queen or a card bearing a prime number. So for this, first we will have to find out the number of queens in a pack, and that will be equals to 4. Just because we have 4 suites and a standard pack of 52 playing cards, so each suite has its own queen, and so the total number of queens in a pack is equals to 4. Now since we have numbers from ace to 10, so the prime numbers are 2, 3, 5, and 7, and that is equals to 4. So the number of cards bearing a prime number will be equals to 4 add 4 add 4 add 4. And that will be equals to 16. Since every suite has its own card bearing a prime number in a pack, that the card is drawn with a queen or a prime number are mutually exclusive events. So here we will apply the additive law of probability. So the probability of queen plus the probability of a prime number. So the probability for the queen will be 4 over total number of cards 52 plus the number of cards bearing a prime number in a pack was 16. So here we have 16 over 52. Now we will add 4 and 16 and divided it by 52. So here we have 20 over 52. And after simplification, we will get 5 over 13. So the probability that a queen or a prime number is equals to 5 over 13. Now in the part 3, we have to find the probability of drawing a card bearing a number that is divisible by 3 or by 5. So first we will see, since each suite has 13 cards, and those are ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now first we will see the numbers that are divisible by 3. Those are 3, 6, and 9. Now we will use the red color for the numbers. Those are the multiples of divisible by 5, and those are 5 and 10. Now, since we have 4 suites, so again we will write down the numbers. Now we will use the red color to mark the numbers that are divisible by 3. And we will use the black color to mark the numbers that are divisible by 5. So now to find out the probability that a card bearing a number that is divisible by 3 or by 5, first we will have to find out the number of cards bearing number divisible by 3. And that will be equals to, so now we will count the numbers in red. Those are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that will be equals to 12. Now we have also find out the number of cards bearing number divisible by 5. Now we will count the numbers that are marked in black, and those are 1, 2, 3, 4, 5, 6, 7, and 8. That will be equals to 8. Now for the probability that the numbers divisible by 3 or 5, and these two events are mutually exclusive events. So here we will apply the additive law of probability. So the probability for the divisible by 3 at probability divisible by 5, and that is 12 over 52 add 8 over 52. Now we will add 12 and 8 over 52, and here we have 20 over 52, and after simplification we will get 2 over 13. After simplification we will get 5 over 13. So the probability that the number divisible by 3 or 5 will be equals to 5 over 13. Now in the part 5, we have to find out the probability that a card bearing a number that is divisible by 2 or by 3. So for this, first we will write down the numbers that we have in the 4 suites, and that those are A's 2, 3, 4, 5, 6, 7, 8, 9, and 10. Similarly, again, A's 2, 3, 4, 5, 6, 7, 8, 9, and 10. A's 2, 3, 4, 5, 6, 7, 8, 9, and 10. A's 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now we'll use the red color to mark the numbers that are divisible by 2. Those are 2, 4, 6, 8, and 10. 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 And now we will use the green color to mark the numbers that are divisible by 3. Those are 3, 6, and 9. 3, 6, and 9. 3, 6, and 9. 3, 6, and 9. Now, we will find out the number of cards bearing number divisible by 2, and that will be equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So here we have 20. Now we will count the number of cards bearing number divisible by 3. Since the number 6 is the number that is divisible by both 2 and 3, since we have count the number 6 as a number of cards bearing the number divisible by 2, so we will exclude the number 6. And we will consider just 3 and 9 as numbers that are divisible by 3. So here we have 1, 2, 3, 4, 5, 6, 7, and 8 number of cards that are bearing the numbers divisible by 3. Now, the probability that the number divisible by 2 or 3 will be equals to the probability of the number divisible by 2 add the probability of divisible by 3. Since we have find out the number of cards bearing the number divisible by 2, that is 20, and the total number of cards are 52. So here we have 20 over 52. Now for the probability, that the number of card bearing divisible by 3, and that is equals to 8 total number of cards, it's 52. So here we have 8 over 52. Now we will add up 20 plus 8 over 52. So here we have 28 over 52. Now after simplification, we have 7 over 13. So the probability that a card drawn bearing a number that is divisible by 2 or by 3 will be equals to 7 over 13.
In the question 8, in a basketball tournament, three of the participant teams are alpha, beta, and gamma. The probabilities of each of these three teams winning the tournament are 4 over 15, 1 over 10, and 1 over 5, respectively. Only one team can win the tournament. In the part 1, explain why there are more than three teams in the tournament. So, for the part 1, since only one team can win the events of each of the teams alpha, beta, and gamma. Winning are actually exclusive. are mutually exclusive. But probability of alpha wins equals plus probability of beta wins plus probability of gamma wins. So the probability of the three teams winning the tournament are given, and they are 4 over 15 plus 1 over 10 plus 1 over 5, respectively. Now we will take the LCM of 5, 10, and 15. So here we have 5. 5 ones are 5. 5 twos are 10, and 5 threes are 15. And here we have 2. The 2 ones are 2, and here we have 3. No, 3. 3 ones are 3 is 3. So 5 times 2 times 3 is equals to 12. Its LCM is 30. So we will use the butterfly rule. Here, 15 times 2 is 30. So 4 times 2, add 10 times 3 is 30. So 1 times 3, add 5 times 6 is 30. So 1 times 6. 4 times 2 is 8. Add 3 times 1 is 3. 6 times 1 is 6 divided by 30. Now adding up, we will get 17 over 30. So the probability of the alpha wins add beta wins add gamma wins is less than 1. Therefore, there are more than 3 teams in the competition. There are more than 3 teams in the tournament. Now in the part 2, calculate the probability that either alpha or gamma will win the tournament. So for this, probability that either alpha or gamma win will be equals to probability of alpha win add probability of gamma win. Since the probabilities of alpha and gamma are given in the questions respectively, and those are 4 over 15, add 1 over 5. Now we will take the LCM of 5 and 15. So here we have 5 ones are 5, and 5 threes are 15, and here we have 3. So 3 ones are 3 is 3. And 5 multiplied by 3 gives us 15. So the LCM is 15. 15 times 1 is 15. So 4 times 1 plus 5 times 3 is 15. So here we have 1 times 3. Now 4 ones are 4 is 4. Add 3 ones are 3 is 3. And divided by 15. Now after ending up, we will get 7 over 15. So the probability that either alpha or gamma wins is equals to 7 over 15. Now in the part B, I'll calculate the probability that alpha, beta, or gamma will win the tournament. So in the part B, we have to find out the probability that either one will win. And that will be equals to probability of alpha wins add probability of beta wins add probability of gamma wins. Now the respective probabilities already given in the question, and those are 4 over 15 plus 1 over 10 plus 1 over 5. And after solving, we will get 17 over 30, as we have find out in the part 1. So the probability that either one will win is equals to 17 over 30. Now in the part C, we have to calculate the probability that neither alpha nor gamma will win the tournament. So for this, we will subtract the probability of either alpha or gamma win from 1. Since the probability of either alpha or gamma wins, we have already find out, and that was 7 or 15. Now we have 15 minus 7 over 15, and that will be equals to 8 over 15. So the probability that neither alpha nor gamma win is equals to 8 over 15. Now in the part D, we have to find out what is the probability that none of these three teams will win the tournament. So for this, the probability of either one will win from 1, and the probability of either one will win was 17 over 30. Now we have 30 minus 17 over 30, and after subtraction we have 13 over 30. So the probability that none of these three teams will win is equals to 13 over 30. Now in the part 3, without doing any calculation, explain why the probability of neither alpha nor gamma wins is not equals to probability of alpha does not win plus probability of gamma does not win. The events of not winning are not mutually exclusive. Since there since there will be more than one team that will not win.
This means that,
Or in other words,
alpha does not win. The event alpha does not win. Does not exclude the event gamma does not win. Similarly, the event gamma does not win. Does not exclude the event alpha does not win. So here the solution ends. Now, in the question 9, the probabilities of four teams E, F, G, and H winning a hockey competition are 1 over 3, 1 over 5, 1 over 7, and 1 over 11, respectively. Only one team can win the competition. So, in the part 1, explain why there are more than 4 teams in the competition. Since only one team can win, so the events of each of the teams E, F, G, and H winning are mutually exclusive. So here we will apply the addition law of probability. So the probability of events add probability of F wins, add probability of G wins, add probability of H wins. And that is equals to 1 over 3 plus 1 over 5 plus 1 over 7 plus 1 over 11 respectively. Now we will take the LCM of these four numbers. Those are 3, 5, 7, and 11. So here we have 3 ones are 3, 5, 7, and 11. 5 ones are 5, 7, and 11. 7 ones are 7. And at the end we have 11. Now we will take the product of these four numbers. Those are 3, 5, 7, and 11. So the LCM is, so the product of these four numbers is 1, 1, 5, 5. Now here we have 1, 1, 5, 5. Now first we will check. 3 divides 1, 1, 5, 5 where? So 3 is a 9. So we have 25. 3 is a 24. And we also have 15. So 3 5 is 15. So according to butterfly rule, we have 1 multiplied by 3 into 85. Now we will check where 5 divides 115. So here we have 1155. Not 65. Here we have 5. 5 ones are 5 again. Now we have 15. And now we have 5. 1 multiply 1131. Now for 7, we will check. Here we have 1155. 7 ones is 7. 45. 7 6 is 42. 7 5 is 35. So here we have 1 multiplied by 165 plus. Now we will check for 11. Here we have 11. 11 on the 11. Now here we have 0 just because we have take two values down at a time. And 11 5 is 55. So here we have 1 multiply 105. Now we will add all these numbers. So here we have 385 plus 1131 plus 105 plus 165. So here we have 886 over 1155. And that is less than 1. So therefore, there are more than 4 teams in competition. Now in the part 2, we have to calculate the probability that either E or F wins. So the probability of either E or F win will be equals to the probability of even plus probability of F wins, just because these two events are mutually exclusive. So that's why we have applied the additive law of probability. Now, since the probabilities of for the team E and F are given, and those are 1 over 3 plus 1 over 5 respectively. Now, after taking the LCM, we will get 15. So 3 5s are 15, so 1 times 5 plus 5 3s are 15, so we have 1 times 3. Now 5 1s are 5 is 5, add 3 1s are 3 is 3. So we have 15. Now, after adding up, we will get 8 over 15. So the probability that either E or F win is equals to 8 over 15. Now, in the part B, we have to find out the probability that F, G, or H wins. So, to find out the probability of F, G, or H wins will be equals to the probability of F wins plus the probability of J wins plus probability of H wins. And the probabilities of these three teams already given in the question, and those are 1 over 5 plus 1 over 7 plus 1 over 11. Now we will take the LCM of these three. Since these three numbers are prime numbers, so we will just take the product of these three numbers, and that is 385. The LCM is 385. Now we will check the three numbers one by one, where 385 divisible by 5. So here we have 5 sevens are 35, and again 5 sevens are 35. So here we have 1 multiplied by 77. Now 385 for 7. 7 fives are 35, and 7 fives are 35. So here we have add 1 multiplied by 55. Now for 11, 385 divisible by 11. 11 threes are 33, and 55. 11 fives are 55. So here we have 1 multiplied by 35. Now we have 77 plus 55 plus 35 over 385. And after adding these three numbers, we have 167 over 385. So the probability that F, G, or H wins is equals to 167 over 385. Now in the part D, we have to find out what is the probability that none of these three teams will win the tournament. So for this, now in the part C, we have to find out what is the probability that F does not win. So we can find out just by the probability of F wins by subtracting the probability of F wins from 1, and that was 1 minus what is the probability of the F wins, and that is 1 over 5. So here we have 5 minus 1 over 5, and it will become 4 over 5. So the probability that F does not win is equals to 4 over 5. Now in the part D, we have to find out the probability that F, G, and H do not win. So we can find out it just by subtracting the probability of F, G, or H win from 1. Since we have find out this probability in the part B, and it was 167 over 385. Now it will become 385 minus 167 divided by 385. And after subtraction, we will get 218 over 385. So the probability that F, G, and H do not win is equals to 218 over 385. Now in the part 3, without doing any calculations, explain why the probability of F, G, and H do not equals to probability of F does not win plus probability of G does not win plus probability of H does not win.
So for this,
the events of each team, F, G, or H, not winning are not mutually exclusive. Since there will be more than one team that will not win. That will not win. This means that the event F does not win, does not exclude, the events G does not win, and H does not win. Similarly, the event G does not win exclude the events F does not win and H does not win, and the event H does not win does not exclude the events F does not win and G does not win. So now we will write down here. Similarly, the event G does not win does not include, does not exclude events F does not win and H does not win. Last but not the least, the event H does not win does not exclude the event G does not win and F does not win. So here the solution ends. Now in the question 10, in a probability experiment, 3 fair coins are tossed, one after another. So first we will have to display the possible outcomes of the experiment using a tree diagram. So for the first coin, we have two outcomes, head and tail. Now for the second coin, we have head and tail, head and tail. And now for the third coin, we will start from the head of the second coin. Now for the tail, head, tail. Now we have again head, tail. And again we have head, tail. So here we have 2 cross 2 cross 2 is equal to 8 outcomes for this probability experiment. Now, for the experiment, the events A, B, C, and D are defined as follows. A, all 3 coins show heads. B, at least 2 coins show tails. C, exactly 1 coin shows a head. And D, the faces appear alternately. For each part, identify if the following events are mutually exclusive. So in the part A, we have A and B. Since the event A is all 3 coins shows heads and B is at least 2 coins show tails. So there is nothing in common between these two events. So A and B are mutually exclusive. Now for C and D, since C is exactly 1 coin shows a head and D, the faces appear alternately. So C and D are not mutually exclusive. The faces appear alternately means Head, tail, and head. Exactly one coin shows the head. So the faces appear alternately. So C and D are not mutually exclusive just because there is something in common between these two events. Now in the part C, we have B and C. B and C are not mutually exclusive. Since the outcomes HTT, THT, and TTH are favorable to both events. Now in the part D, we have A and C. The A is all three coin shows head, and the D is the faces appear alternately. So these two events, A and C, are mutually exclusive. Just because these two events have nothing in common between them. Now, in the part E, we have to find out for B and D. Since B and D are not mutually exclusive, because the outcome THT is favorable to both events. Now, in the part F, we have A, B, and C. Since A, B, and C are not mutually exclusive, have a look on the events A, B, and C. The event A is all three coins show heads. The B is at least two coins shows tails, and the C is exactly one coin shows a head. So the outcomes HTT, THT, and TTH are favorable to B and C. B and C. Now we have question 11. In a game, Yasser attempts to score a penalty kick against a goalkeeper who will try to save his shot. There is an equal chance that he will score or miss his penalty kick. Yasser has three chances to score, and the game ends once Yasser scores a penalty kick. In the part 1, draw a tree diagram to show all the possible outcomes. What is the total number of outcomes? So, the first kick gives us two outcomes. Miss the goal, miss his penalty kick, or score. Now from Mrs. Miss his penalty kick in the second kick from M. M means Miss the penalty kick, and S means score. So scored the penalty kick. So from the M of the first kick, we will have two more outcomes. Those are M and S. And now for third kick. From the M, we have further to so the total number of outcomes is 4 in our case. So the total number of outcomes and since the Yasser has 3 chances to score, so that's why we are talking about 3 kicks. And the game ends once Yasser scores a penalty kick. So when the Yasser scores a penalty kick, the game ends there. So here we have 1 chance, 2 chance, 3 chance, and the last chance is the here. So that's why the total number of outcomes is 4. Now in the part 2, events A and B are defined as follows. A is exactly 2 penalty kicks are attempted, and B at most 2 penalty kicks are attempted. Are A and B are mutually exclusive events? Explain. No. A and B are not mutually exclusive. The outcomes were first kick is a miss, and the second is a score. Is favorable to both events. This is just it's just like the first is a miss and the second is a score. Since in the event A, exactly 2 penalty kicks are attempted, it means we have just like this. So here we have miss, miss, and the score. And for the event B, we have at most 2 penalty kicks are attempted. It means we have more than 2 penalty kicks. So A and B are not mutually exclusive events.